6.4. We're talking about 6.4 today and Tuesday. I'm not talking about anything with you guys on Monday.
No.
Okay.
And then
You're
there's
gonna get a Wednesday, I have as a review day. I have a quiz scheduled on Thursday. Okay. If we have weather's supposed to happen over the weekend, cold is supposed to happen next week. If we have an e-learning issue, okay, an e-learning day, check Schoology. I could throw an AP Classroom assignment at you. I could say get your review worksheet done. I don't know.
What are your AP Classroom assignments? Like I know you told us they were derivatives or.
I have one I have three basic ones that I use on and off from year to year. I mean, I can set anything up that I want, but I have three basic ones: a limit one, a derivative, and an integral.
Is it like multiple choice or is it we watch a video?
No, it's like answering questions.
Oh, okay.
Sorry,
It's like I wonder if it'll be like PPC or if it'll be like.
I think they're multiple choice usually. I think it's just multiple choice. Like I'll assign like 10, 15, 20, I don't know, multiple choice.
I was trying to think like AP Chem.
No. Sorry, I was like, I don't understand what you're asking, but it'll be
like we get 3 questions on video like every day.
Okay, no, that's not.
So I was like, how?
This is like I created I don't know if they might be called a quiz or something. It's not, it's just an assignment.
Is it progress check questions? Probably.
It's like the same idea as the progress check, but it's the ones that I just handpicked and said, okay, this looks like something we can handle. This looks like something we can handle. So, okay. Lesson 4. We are looking at properties of definite integrals. Okay, so we move beyond finite sums, in other words, the adding of the rectangles, and explore what happens in the limit. As the terms become infinitely small and the number of rectangles approach infinity, we'll look at some geometric functions that may contain negative values below the x-axis as well as positive values above the x-axis and 0. So we've already talked a little bit about dealing with negative area. We're doing that more. At times we integrate functions that go below the x-axis. Well, keep in mind, when we've been doing this geometrically, like by hand, anything that's below the x-axis takes on a negative value, right? So when we do these integrals, that will, take care of itself, but area below the x-axis counts as negative area. The total area between A and B for some curve is really a net area, where the total area below the x-axis and above the curve is subtracted from the total area above the x-axis and below the curve. Like, in other words, when we have an integral that is set from A to B, if your curve is in both places, both above the x-axis and below the x-axis, it will automatically take care of itself, okay? And so that will just be based on the equation and your interval values. Okay, Leibniz introduced the notation for the definite integral. The Greek letters of summation become Roman letters in the limit. So this notation that I've talked about a little bit, right? Couple different ways. I mean, if me just looking at it, and I'll make it more fit, the integral from a to b of f of x dx, okay? Now, officially, first one we talk integral, it is a definite integral. Anytime you have those a and b limits, it's a definite integral because we have that specific interval we're working on. We will also talk indefinite integrals where we don't have those bounds, but that's a story for another day. So the definite integral from a to b, or on the interval from a to b, and then if we want to get official, it's from a to b of f of x with respect to x. So that dx talks about, when I read it, I usually just read dx, but it talks about with respect to what variable that we are integrating. We kind of talked about that a little bit with derivatives. It's the same type thing here. So if I put some words down, I'm going to say the definite integral from A to B, we're on the interval from A to B, of f of x And that's just putting it into words, you know, we usually use the f parentheses x. With respect to x. Okay. And there's other slight variations you'll hear on that, but, you know, that's some official wording for you. Come on, you're in calc. You gotta have some respect for x here.
Why?
Okay. Let's talk about these component part names. What's that little curly Q sign?
Integral.
Okay, this is your integral sign. It's probably about the one and only time you'll hear me call it the curly Q sign. Because even from day one, what have I been calling it?
Integral.
An integral, right? I've never called it the curly Q sign, but okay. A and B, those are our limits, our bounds. Okay, so A is your lower limit. I think officially in here, officially it says it's your lower limit of integration. It's your lower limit, or you'll sometimes hear lower bound. So lower limit of integration. And what's that make B?
Upper.
The upper. You could say upper bound, upper limit of integration.
Function.
What are you talking about?
Function.
F of x?
Yeah.
It is the function, but I'm going to call it the integrand. The integrand. Okay. It is the function you are integrating, if you will, also known as the integrand. Now, you know, I've been using the integral sign from day one. Integrand, I don't usually use integrand. Maybe some calc teachers do, but that's not my
Instead of a D.
vocabulary. Okay. Dx just says that the variable of integration is x. Not Jesus, it's x. Variable of integration is x. Okay. And then that bottom blank is for the name of the whole thing.
Definite integral.
It is the definite integral.
My hands are sweaty.
Is there any such thing as an indefinite?
Yep.
What is it?
Take off the a and b. It's an indefinite integral. We'll talk about that another day.
Oh,
Or maybe we'll talk about it today. I don't know. No, I don't think we talk about it.
Never.
We do talk about it somewhere, but not yet. Well, okay, this lesson, now that I go back and look at the title, is properties of the definite integral. So indefinite will come, but we're not there yet. Okay. Definite integral can be used to determine. What are we determining here?
The area.
The area. So when we talk about its area from A to B, I have in here the word net area. Okay. The net area or the displacement bounded by the x-axis, the function f of x, and basically your boundaries A and B, but the vertical lines formed by A and B. So like if you have a curve here, yes, that goes from A to B. Basically, it's finding the area that is bounded by whatever this function is, the x-axis, and the vertical lines x equals A and x equals B. Okay? So, I'm going to say it can be used to determine the net area, also referred to as displacement, bounded by the x-axis, the function f of x, and vertical lines, x equals A, and x equals B. Okay. I feel like some of what we're doing here is familiar in terms of we've already done a little bit in 6.1, 6.2, and 6.3, okay, or whatever variations of those. But when you turn the page to example 1, it asks us to use the graph. So we're still, right now, we're not finding antiderivatives yet. We're doing integrals, but we're not finding antiderivatives yet, okay, because we're doing this geometrically, which is a skill that you have to keep in mind. Even when you get into hard calculus, there's times that you have to remember, I can do this geometrically. Maybe I don't know how to take the antiderivative of that function, but oh, I have a graph here. I can do this geometrically. Okay? So, using this graph, we're going to note that the graph of f of x consists entirely of line segments and a semicircle, and it's on the interval from -8 to 13. So, A, the integral from 0 to 7 of f of x dx.
20.
What?
I count squares. That's probably not right, but I'm gonna try it.
Okay,
Nuh-uh.
so it is a big old, from 0 to 7,
You got that?
is a big old trapezoid.
I know I count the right squares, but I'm saying it's the actual area 20 when you add it up.
Well, it's a trapezoid, 1/2. What's the height between the parallel bases? 4. And then we add the bases. We have a bottom base of 7, a top base of 3.
10.
4 times 10, 40 divided
Oh,
by 2.
sorry.
20.
You know, I probably should have done that work right there in that box, but I didn't. I did it off on the side, which is exactly where I have it done over here. Okay, so this carries an area of 20. Okay,
Yeah, but
B. Now what?
The
So
next
13.
0 to 13.
you subtract the bottom area.
So we know we have 20 from 0 to 7. We know this bottom area is below the x-axis, so we are subtracting. This again, you can try counting your rectangles, but what will definitely work, and that is a trapezoid again, 1/2, a height of,
-3. All 3.
I'm going to say 3 because I've already addressed the subject that we are subtracting, right? In my brain, I just know it's negative.
Got -13.
We have bases of 3 and
9. Or 6.
What's fine? Maybe it's 27.
so
1/2 times 27.
okay. I came up with 27/2, which is indeed 13.5. We are below the x-axis, so we are subtracting that 13.5,
6.
and we are at 6.5. Okay. Moving along.
Oh, it's a semicircle.
C. -6 to 0. You can assume, but they also told us that this is a
So
semicircle.
you'd go
What about the area? What's the area of a circle?
pi r.
Nope. Pi r squared. Nope.
So you should divide by 2. Oh, yeah. I'm done.
I would say 1/2 pi r squared. Some of you might say pi r squared over 2. Same thing, right? is my radius here? The diameter is 6, so the radius is 3.
You said 6.
So 3 squared is 9. You guys are scaring me. So we have, I was going to say 9/2 pi.
Is it better to leave it in pi form?
We are leaving it in pi form. Now, because this is below, we're going to say negative 9/2 pi. You can either say 9/2 pi or 9 pi over 2. And it is negative because it is below. D. Done?
Yeah.
The integral from 3 to 3. One of our properties, we'll have a big old list of properties at some point. And one of our properties is when your upper and lower limits are the same, the answer is 0. Period, end of statement. There's no work to go into it or anything. Okay. E.
-20.
Negative 20.
Okay, so,
Because they flipped it.
So then it's.
okay, wait, which one was, I did that. So, and I'm just flipping back and forth because I wanted a picture big enough I could actually draw on and do stuff. So, instead of me having all one page, I flip back and forth. I've talked about one of the limits is you flip this, and so it's the negative of 0 to 7. And what did we already say the integral from 0 to 7 was? That was 20, so this is going to be negative 20. Okay? Now, we haven't done 4 to 10 yet, have we? No. So this is going to be a new problem, just making sure. Now, what do you need to think about first? It's going to be the negative of the integral of whatever 4 to 10 is. So we're going to have to go back to the other page and figure out, well, my other page, not your other page, 4 to 10. Yes? Do I have time?
Not really.
Yeah, we do.
Okay.
Okay. I hope. 4 to 10. Oh, man. Ugh. So I see 2 trapezoids is what I see.
Yeah.
First trapezoid, the one above, has a height of 4 and bases of
1 and 3.
1 and 3.
Got 8.
So the trapezoid above is 8. And then my trapezoid below, it's a height of 3, bases of 3 and 2. Well, it'll just all be I'll make it negative in the end. So
-7.
15/2, which is 7.5, right? So this is negative 7.5 on the below trapezoid. Okay, so see, I just did 7.5 and then I will subtract. And so now, basically I'm going to be doing 8 minus 7.5 and getting,
-0.5.
So would that be positive because it's in a
oh, because it was negative here. Okay. So,
Yeah.
my apologies, I forgot. This is going to be the negative of 8 minus 7.5, so thus, negative 0.5. I'm just showing you what mistakes you can make and how easy it is to forget these details. Okay, so we will pick up on what? Part G on Tuesday. Right?
Yep. Well, that's gonna be tough.
Okay.
It's like a 4-day weekend.
3?